An absolute value equation is one where the x variable is inside the absolute value bars. And generally speaking, to solve that, we want to make sure that the abs-vals are isolated on one side of the equation, and on the other side of the equation we have a positive constant. So once these two things are satisfied, then we want to split this up into two equations. We want to set what's inside the abs values equal to the positive constant and what's inside the abs values equal to the negative constant. Basically what that means is that the quantity that's inside the abs val bars could be equal to positive 10, or what's inside could be equal to negative 10. And in this first example, these would be our two solutions. And we could check these two solutions back into our original equation, plugging positive 10 in for x, which is going to give me a true statement, and the absolute value of negative 10 is also going to be equal to positive 10. Now this was a pretty basic example, but we're going to follow the same steps when it gets more complicated. Here, let's notice that step 1, the absolute value bars are isolated on one side. However, step 2, we need to make sure that there is a positive constant over here on the other side. And in this situation, there's not. In this example, there's going to be no solution, because there's no value of x that we could plug in that would cause the output of the left-hand side to yield a negative constant. Any number plugged in for x on the left, once we take the absolute value of that quantity, we're going to equal to a positive constant, and so there's no value of x that would solve this equation. So here we are with another example. Remember, our first step is to isolate this absolute value expression by adding 3 to both sides. On the left-hand side, we just have our abs val bars. On the right-hand side, we're equal to 11. Now here is where we want to be sure to have a positive constant on the other side. Once our absolute value bars are isolated, the number that's on the other side has to be positive. Since we do have that in this situation, we'll move on to the next step, which is to split this up into two equations. Notice that if the inside of this absolute value bar was equal to the positive 11, its abs val would be equal to positive 11. So we create an equation from that situation, saying what's inside could turn out to be positive 11. But if that inside turned out to be negative 11, its absolute value would also be positive 11. So the inside of those abs val bars could also have turned out to be negative 11. So what we did was we set the inside equal to the positive constant, and we also set what was inside equal to the negative constant. And now we'll solve each of these equations individually by subtracting 1 from both sides. Let's do it in both equations. So on this equation, we get 2x is equal to 10, and when we divide both sides by 2, we get x is equal to 5. And in this equation, we get 2x is equal to negative 12, and when we divide both sides by 2, we get x is equal to negative 6. And both of these solutions would check back into the original and make a true statement. So let's do one more example. Remember, we start by isolating the absolute value bars. So we'll subtract 4 from both sides. To get 2 times that absolute value is equal to positive 8. Now let's get rid of this 2 here by dividing both sides by 2. And now our absolute value bars are completely isolated. So it's time for the second step, which is to check and make sure that we have a positive constant on the other side once the absolute values are isolated. If it were negative at this step, we would stop and say there's no solution. But we do have a positive 4 over here, so it is safe to continue with this problem. The next thing that we want to do is to split this into two equations, where we set the inside of the absolute value bars equal to the positive constant, but we're saying that that inside could also turn out to be a negative constant, and its absolute value would still be positive 4. So again, to say what's inside here could turn out to be a positive 4, so we create an equation from that possibility. But what's inside these absolute value bars could turn out to be a negative 4, and the absolute value of negative 4 is also positive 4. So what's inside could also be negative 4. So now we solve each of these individually. Here we have 4x is equal to 6, and then we divide both sides by 4. To get x is equal to 6/4, that reduces to 3/2. In the second equation, we'll again add 2 to both sides to get 4x is equal to negative 2. And when we divide both sides by 4, we get x is equal to negative 2/4. That reduces to negative 1/2. And these are our two solutions to that last example.